Number 5, we're trying to solve the systems of equation using the substitution method. So our goal is the same as the previous problems where we're finding the intersection point, but we're just going about it in a different method. We're using an algebraic method rather than a graphic method. But our end goal is still the same. So my first step is I need to isolate for one of my 4 variables. So I either need to get the blue x by itself, or the blue y by itself, or the green x by itself, or the green y by itself. And any one of these will work. I think the easiest one to get by itself is the green x. So if I subtract 3y from both sides, I get x is equal to 2 minus 3y. My next step is to plug this equation, or the right side of the equation, into the other equation. So I want to plug it in for x, and make sure you plug it in for x in the other equation. So that's going to look like this. I'm going to put 7, I'm going to put a big open parentheses, minus 3y is equal to negative 10. So that is the top equation with a blank space instead of x. And then I'm plugging in the other equation, so 2 minus 3y. So right now I have essentially one equation plugged into the other equation. You'll also notice that we have all y's here. So I have two different color y's, that's okay, but I have all y's. You want to make sure that you have either all y's or all x's. If you have kind of a mix and match, then you've done something wrong. So that's kind of a check. Okay, so let's simplify now and solve for y. So if I distribute, I have 14 minus 21y minus 3y is equal to negative 10. Let's continue to combine like terms. And if I move the 14 to the other side, then if I divide both sides by negative 24, I get y is equal to 1. Okay, so we have the y coordinate of our point. Now our last step is to get the x coordinate of that point, because again, we always need an x and a y value. So I'm actually going to plug that into here. You could plug it into one of the original 2, that's fine, or you can plug it into this original one which is being rearranged. And I'm going to do that because I'm solving for x, and x is already by itself here. So I'm going to do x is equal to 2 minus 3y, but instead of y I'm going to plug 1 because I know that y is equal to 1. So x is equal to 2 minus 3, or x is equal to negative 1. So my final answer would be negative 1, 1 as an ordered pair. So this would be the intersection point of these two lines.